Hello. Probability is the main instrument to study science, physics, chemistry, engineering, and everything in this world has some conditions. So the probability needs to be studied within the conditions. So we are going to introduce conditional probability. So conditional probability means that you already have a probability space and then you have some information or some conditions. So the knowledge of these information or conditions or whatever you know will change your probabilistic view on the rest of your sample space. So conditional probability is the instrument which allows you to put conditions, observations, and later on we'll expand it, we'll use it as inference, estimation, detection, decision making, and all the processing that you do using machine learning, all the computers, computing, communications, and so on. They need to deal with conditions and probabilities. So suppose that we have a probability space which is a triplets, and then we have two events. Okay. Now the conditional probability of the event A, assuming the event M, is denoted by a new probability. We say the probability of A given M, or conditional probability of A given M. So again, we will prove that this is a valid probability measure, but it's different because now I know that M is happening. And the definition of the conditional probability is based on this equation. I say that probability of A given M is a number which will satisfy this equation. Okay? So is a real number because this guy, the first guy, the probability of M is a number between 0 and 1, so it's non-negative, and the probability of intersection is between 0 and 1. Therefore, this guy should be non-negative. It cannot be negative. This guy cannot be bigger than 1 because now if probability of M is 0, if this guy is 0, in that case, this 0, this equation disappears because you will have intersection of A and M will be, this probability is less than probability of M. This is 0, so therefore is 0. So I get 0 equal to 0. So this definition disappears. So conditional probability is well defined with probability of M is not 0. So in that case, if this is not 0, I could define both sides by probability of M, and I will get probability of A given M equal to probability of A intersection M, and then divided by probability of M. Obviously, you could have defined probability of M given A, which would have been slightly different with this one. So we refer to this probability. We haven't shown yet that this is a probability and it is a probability measure, but it's easy. You can do it very easily. We refer to this as the conditional probability. Because we will show that this is a probability measure, conditional probability will form a probability space, form a new matrix. And the values are different. The value of probability will change because as soon as you know M is happening, so probability of A given M, and this is the main instrument for estimation, detection, inferences, machine learning, everything else. This is the main. Now let us have one very simple example of conditional probability. Suppose that you roll a fair die. So your possible outcomes are 1, 2, 3, 4, 5, 6. And let us consider the event of observing an event which is even number. So if A is an even number, I define it AE, and another event A, okay, 1, 2, 3. So probability of A is 1/2. Probability of AE also is equal to the size of AE divided by size of L. This one has 3 members, this one has 6 members, and this is also equal to 1 over 3. Now, intersection of A, intersection with AE, is equal to, what are the elements which are both in A and AE? So it's only 2, okay? Only 2. So probability of this guy, probability of A intersection AE, is equal to size of this set, which is 1, divided by size of total set, which is 6, 1 over 6. So now if I want to calculate conditional probability, I have to put this one in the denominator and the probability of AE here, so I get 1 over 3. So this is the conditional probability. So this is a very important, very trivial theorem which says that if you have a probability space, which is a triplet, and let's say you have an event M, okay, and probability of M is not 0, then I could define a new measure of probability, which I call it conditional probability, for all A inside F. In that case, the triplets, the new triplets, L, F, and the new with the new measure, okay, the new measure is the measuring the probability with the condition that we know M is happening. This is also a probability space. It will satisfy all the conditions that we had in our definition. So this is called a conditional probability space, triplets which has. So the proof is very easy. The first component of the proof is that prove that probability of everything is non-negative. This is very trivial because probability of A given M is equal to the probability of A intersection M divided by probability of M. This is non-negative, this is 0, so therefore this is non-negative. So the first property is easy. The second one is that probability of P M of L, the probability of L is equal to 1. So obviously this is by definition, because this should be probability of L given M, and this by definition is equal to this one. So this is also satisfied. The third property is the additivity property. So if you have a sequence of pairwise disjoint sets, this means that the intersection of A1, because if A1, A2, etc., they are disjoint, A1 and M also are this set and this set are disjoint. This one and third one is disjoint. So the probability, the conditional probability for their union is equal to probability of union given that, and then you can write it that. So you know that union of AI intersection M, okay, is equal to intersection of over I of AI union of union of AI and then intersection of M. Okay, and these guys are disjoint, so probability of this one becomes sum of the probabilities, and you can see that this is just probability of M, so because this is the definition of the conditional probability. So the third property is also satisfied, and therefore you have the conditional probability space. Is it valid probability space? So, so this is already proven.